Okay, so determine the voltages across the two capacitors in the circuit under DC conditions. And it looks like I have a lot of work on my page and a lot of work scribbled out. And so, yeah, so we'll see. Okay. First of all, under DC conditions, we know that our capacitors act like open circuits. So I'm going to redraw the circuit with the capacitors as open circuits. You don't have to do this step, but it helps me. Okay, so this is how the capacitor acts under DC conditions, and we are supposed to figure out the voltage across the two capacitors. Now, you might notice that this capacitor right here, the one that I'm about to mark in red, this one is in parallel with this resistor because there's no current flowing through this 10 kilo ohm resistor up here because of the open circuit. There is current flowing through this 20 kilo ohm resistor right here because we do have a complete circuit up here. So as a matter of fact, I'm going to redraw the circuit actually without the capacitors at all, just so we can see the parts that have current flowing. So this time I'm just drawing the parts that have current. Okay, so basically, so what I did was I took off this branch and this branch, and I'm just left with this inside sort of T part. And now this, in my beautiful drawing, it's 2 volts. This is 3 kilo ohms. I'm not going to write the ohms. This is 20 kilo ohms. This is 10 volts. This is 40 kilo ohms. This is also 40 kilo ohms. And this is 3 kilo ohms. Okay, so let's see what I did. Okay, I was looking at my notes hoping that with all these scratch outs that there's an easier way, that I found an easier way to do it than what I ended up doing, but I didn't. There probably is an easier way, but this is what I did. So I'm trying to find the voltages, because if I find the voltages, well, then I can find the voltages across the two capacitors. So I'm trying to find voltages. But to do that, I'm going to first find the currents, and I'll do that using a mesh system. So let's first look at, just because it happens to be the one that I did first, I2. And so going around I2 in the direction that I have it, then that would be 3K I2 plus 40K times I2 minus I1, because both I2 and I1 share that resistor, plus 3K I2 again. And then because we're going into the negative side of the voltage source, that'll be -2 equals 0. Let me make sure that matches what I have here. It does. Okay, so now let me do I1. So I'll start with the 20 kilo ohm resistor. So 20K I1 plus 40K times, this time it's I1 minus I2 because we're going in the I1 direction. Anytime you're doing a mesh current, the current that you're going on will be going in the opposite direction of the other current. If you draw all your currents going clockwise, all clockwise or all counterclockwise, which I strongly encourage you to do, it'll just keep things straight. So then plus 40K I2 and then minus 10 equals 0. Now let me check and make sure that matches. It does. Okay. Then it looks like I combined some things and I got 46K I2 minus 40K I1 equal 2. So 46 I2 minus that looks good. Okay, and then 100K I1 minus 40K I2 equals 10. Let's see. 100K I1, 20 plus 40 plus 40 is 100, minus 40K equals 10. Yeah, okay. So now if I divide this top equation, actually, why would I do that? Because they're not in the right order. So let me write these in the right order. So 100K I1 minus 40K I2 equals 10, and then minus 40K I1 plus 46K I2 equals 2. Then I could divide that top equation through by 10, and then I would get KI1 minus 4KI2 equals 1. I'll call that 1K. Or, no, 10K. 10K. Divided by 10. So 10K I1 minus 4K I2 equals 1. And divide the bottom one through by 2 minus 20K I1 plus 23K I2 equals 1. Okay. Alright, so I didn't do that in my notes. And then I could easily multiply the top equation by 2 and then add the 2 together. I don't trust myself to get the right answer. Let's just use the calculator. Except that was 10,000. That was 20,000. And hey, I think I got the right answer. So I1 equals 0.00018 amps, and I2 equals 0.0002 amps, which is the same as 0.18 milliamps and 0.2 milliamps, which doesn't look as bad. Okay, so now let's go back and try to answer our original question, which is what is the voltage across the capacitors. Okay, so now what I'm going to do is I'm going to label this point as V. I'll label this point as V1, and I'll label this point as V. And I2 goes like that. And if I make this ground, then I can say that 0 minus V over that resistor, which is 3K, equals I2, and I2 was 0.00, well, let's just do 0.2 milliamps, and 0.2 milliamps, a kilo times a milli cancels each other out, so I multiply both sides by 3K, I get minus V equals 0.6 volts. Yes, that's right. So this is minus 0.6. And then, let's see, what did I do next? Okay, so also going down here, if this was 2 and the bottom here is ground, then right here is minus 2. So right there is minus 2. So V1 minus negative 2 over that resistor, which is 3K, also equals it equals I2, which is 0.2 milliamps. So 3K times 0.2 milli is 0.6. So V1 plus 2 equals 0.6, or V1 equals minus 1.4. Okay, so now I have V1. Oh wait, V was minus 0.6, right? Yes, minus 0.6. And V1 is now minus 1.4. Okay, so now let's get the voltage right here, and I'll call that V2. So the current running here is I1. So V1 minus V2, do I have that going in the same direction as I1? No, I drew that the opposite direction of I1, so I'll need to make it minus. V1 over V2, V1 minus V2 over 20K equals minus I2, I1, which was 0.18 milliamps. Or V1 is minus 1.4 minus V2 equals 20 times 0.18. Of course, I'm doing this different than my notes, which is dangerous. 3.6, so negative 3.6 volts, or V2 equals negative 2.2. And this V2 is negative. So V2 is 3.2. So if this is 3.2 and this is ground, then the voltage across this capacitor, we have this, the top side defined as plus, then the voltage across the 40 microfarad capacitor is 3.2 volts. So we got that one. Okay, so we still are working on the 20 microfarad capacitor. Let's see. No, we're not working on the 20 microfarad capacitor because we said that the voltage across this capacitor was the same. It was in parallel with the 3 kilo ohm resistor. And since it's in parallel with the 3 kilo ohm resistor, things in parallel have the same voltage. And the voltage across the 3 kilo ohm resistor was V, which was minus 0.6. So the voltage across the 20 microfarad capacitor is minus 0.6 volts.